what I'd like to do today is to give you an overview of a project that we did with some YellowScan technology, and this is within the renewable energy space. So we do quite a bit of business in renewable energy, and with that, it's really tends to be the terrain areas. Basically, anybody with dirt in their title, we're out talking to them. So just a really quick overview of who we are. So Juniper Unmanned, we're sensing and analytics professionals. So we do a lot of project work. However, we're a business partner of YellowScan. So we sell YellowScan equipment. We also are the exclusive distributor in North America for Altus Intelligence, their ORC single rotorcraft, as well as their multi-rotor LRX. So we sell both of those. The company itself started about 5 years ago doing training. So if you remember the UX5 fixed wing craft that Trimble used to sell, every time Trimble sold one of those, our teams went on site and did training for them, both for Trimble and then for TopCon as well. And what we found was that about 90 days after leaving, we would get a call from them saying, hey, we've been flying their product, based on your training. And we just, we fly it every 3 weeks. We're just not getting the same sort of data. So what we did is we pivoted at that time and really focused on doing projects and focusing our efforts on flying higher end platforms and higher end sensors as well. We're a leading LiDAR provider, so I'll talk a little bit about what we do, and then on the data analytics side, so we do a lot of, in terms of products that we deliver to customers. In this case study, there's a lot of different products, including derived products that we create from that source LiDAR and image collection. We do a lot of different, we service a lot of different markets, but these are the ones that we really focus on. Do a lot in the transportation space. I'll talk a little bit tomorrow. I've got a couple of case studies that we've done there. But we've got a broad base of customers, from the U.S. Department of Energy, where we do nuclear site data collection, to DOT, to U.S. Geological Survey. We actually do a lot of I consider R&D work for USGS. So USGS obtains different sensors and platforms, and then contracts with us to actually do the flying for their office in Lakewood, Colorado, which is basically Denver, where we're located as well. So pretty broad base of customers. We also have a pretty broad stable of platforms and sensors. You can see we have things like the Matrice. The Matrice 600 is really our workhorse, and that's the one we use primarily for our LiDAR collection, as well as the ORC. This is the Altus ORC single rotor craft. If we're doing linear projects, we tend to fly that. We have 2 YellowScan surveyors. We have 1 VX20 in-house today. We actually just recently ordered another VX20. The VX20s that we have, we run them with the dual camera system as well. So we have the 2 A6000 Sonys running on them. And then we just ordered, we're going to turn this into a dual collect as well. So we'll have that bracket with the dual head for the dual A6000s as well, collecting with the surveyor as well. What we're seeing is that most of our customers want to have high resolution ortho photos, as well as the LiDAR imagery. So we're just, even if they don't order it, we're collecting it, and then after the fact, showing them what we have, and then we can upsell, okay? We also fly several other sensors, geometrics. We help them design and test out their magnetometer. So we do a lot of work. In the US, there's a lot of buried pipelines and plugged and abandoned wellheads that aren't correctly mapped. And so we use this to actually identify for land developers where they're going to go in and move dirt. We figure out where these objects are buried underground. And we're seeing wellheads we can see 15 meters below the surface of the earth, okay? And then this is a bathy LiDAR from a group out of Boulder, Colorado called Astrolight. And so we worked with them to test their bathy LiDAR as well. It's a green laser bathy LiDAR, really good product. So what we're here today to talk about is a case study for a wind farm development. And our customer is Res America. Their customer, and it works for this on the project side for us quite a bit. We tend to be a sub, maybe to a sub, sometimes to a sub. So we're 3 levels removed from the end customer. In this case, Tradewind Energy was the actual customer. The build was for this wind energy farm in Kansas, and the ultimate company that runs it is actually out of, I think out of Rome, Italy, called Enel. Enel Green Energy actually is the operator of this project once it was built, okay? So to give you an idea where it's at, this is Salina, Kansas area. It's in the middle of nowhere. The wind blows all the time. But that's why they put the wind energy projects there, right? This is basically Denver, Colorado, where our headquarters is located. But for this particular customer, we've done projects in Kansas, in Eastern Oregon, in South Dakota, and then 3 in Texas. So they like what we deliver, so they keep coming back to us. And that's a testament to our ability and the technology that YellowScan provides. To give you an idea, this is an overview of part of the project area. And just to give you an idea of scale, so that square there is equal to 65 hectares. Okay, so that there is 65 hectares. The project area itself was 19,000 hectares. And over 200 landowners that they needed to work with to get access to the properties. Okay, so a pretty significant effort on their part to actually go out and acquire access to the properties and sign the contracts with this particular customer. And then basically each one of these, when we get to the design level, this is what it looks like, because they're interested in having us collect the access roads as well as the pad sites for each one of these turbines. All right? So here's the problem. They had a busted survey, okay? So they had data, a DTM, that they were using. They put their trucks out on site. Now these trucks cost about, $5,000 to $7,000 per day to have on site. So they're expensive. So when they show up, they need to be working, right? What happened was the truck showed up on site, they started cutting dirt and realized that the DTM was off significantly. So, and this is an area, so this is a road and a pad. So across this whole area, there was 92 wind turbine sites and 345 kilometers of access roads, right? So they stopped development right away. The construction couldn't continue using the existing DTM. They reached out to their partner, a surveyor. The surveyor said, well, we can get it done across this area. It's going to take 4 to 6 weeks, right? Pretty significant delay. They said, we can't do that. So they reached out to us because they didn't want to have the machinery on site. There was late delivery penalties. And probably more important, their contractors, the dirt movers, the guys in the trucks that they're using, they get paid on total cubic yards of dirt moved, okay? I'm going to show you one of the last slides to show you what the difference was between what the survey initially said and what our high-resolution LiDAR with the YellowScan showed. So they called us. We said we can be there in 72 hours. We ended up going with the DJI M600. Again, that's our workhorse for a lot of our LiDAR collection. We use the VX20, not the VX2, LiDAR sensor. We have Trimble GPS rovers and bases that we use. Our professional field operators, so we have a team of 7 pilots and field operation technicians, so we can actually field 3 teams at a time if needed. And then rapid deployment. And we have our own truck with everything in there. So when our guys show up on site, if they need a cable or something, it's in their vehicle. So we don't have to worry about that. And that's pretty important to have that professionalism when you show up on site for a customer. So we said we'd be there in 72 hours. We showed up in 3 days. We collected data across the 62 square kilometers. Our flight missions were a 76-meter swath of LiDAR. Okay, and what I believe we ended up doing on each one of these, we took the center line of the road and we flew offset on that up and back each time to make sure we had really good coverage. Now, this area you can see there's some areas with heavy vegetation, some with not, some actually pretty clear, but a lot of it has sage and things like that, which is a low bush, but we needed to be able to penetrate that, hence the system we went with. Again, they're putting wind energy here because it's windy. We were able to acquire data flying our craft up to 32 kilometers per hour. And then just the site logistics, because some of these, there's no, again, these are in the middle of farmers' fields. So you had to actually, sometimes drag the device to its separate area to actually get a good launch site, okay? And what we tend to be able to do with the VX-20, as long as we have a base station within 3 miles of that, we're able to go ahead and collect it very accurately. Now, in some of these areas where you have heavy vegetation, we'll go and our guys have the GPS rovers, they'll do check shots in really heavy veg to make sure we know what the level of the ground is, okay? So very, very rarely do we not do check shots in areas. We're doing it no matter what. Sometimes we do it to set the ground, sometimes just to validate that the data that we're collecting is accurate, okay? The processing, took about 3 days of data processing, okay? So think about this, 4 to 6 weeks for traditional survey. Within 1 week, actually within 9 days, we were able to get the first call, get the contract, be on site, collect, produce the product, deliver it, okay? Pretty impressive for our team. All right, we've got a great data processing team. And then all the data and the value-added products. So for what they wanted was, they wanted the DTMs. We actually delivered DSMs as well because we had the data. They wanted 1-foot contours. They wanted cut and fill reports for each road and pad, okay? And then they wanted GPS control files, because that's really all they wanted, was to get a control file on a thumb drive that they could hand to a driver, and it would control the blade on the earth movers. Okay, so these are the deliverables. This happens to be a particular pad site. So you can see this is just the terrain, and it's just the data. Oops, let me go back. The data is just colorized by the height of the terrain. That's it, okay? If I go to the next one, let me go back. Okay, I thought I had another one here. This is the ground classified LiDAR point cloud, again, with the design file laid on it for each particular pad, all right? And again, elevation colorization. And here's the bare earth DEM. So again, they're talking about, if they went out with a traditional surveyor, they'd probably get a point every 50 feet, right? And what we were able to do was deliver between 40 to 45 points per square meter. Okay, so incredibly accurate data for them. Also, bare earth contours. So I keep pressing the long button. So again, the same area providing that, and you can see here's the access road, right? And then this is the road leading to it. Now, a couple of interesting things about the access roads. One is they need to move once they build it, they need to move the materials on site to actually build the turbine. The hardest thing to get on site are the blades, because the blades they're 35 meters long each, and there's only a certain angle of the road that it can be. It's got to be very low grade, otherwise they'll bend the blades. So in this case, what the problem as well is, you could think about this, making these turns on some of these roads, they actually had to go on some of these corners and actually grade out to make a longer curve radius so they can actually get the materials on site. These are the cut and fill reports. So we did each of these. There was 92 different pads. So in terms of the deliverable, you did this, and it shows the 2D and then the cut and the fill, okay? And then again, the design files are placed on the center of the turbine pad site, the big development site itself, okay? And then the machine control models. So after we created the files and delivered to them, they take their design files, and they call them 30% files. So they deliver to us, that's what we use initially for our collection, is what they call their 30% files. Then they take those, and then they either raise them up or drop them down into the terrain model to get the least amount of dirt that needs to be moved. Because again, remember one of the first slides, they're paying per truckload, right? So they're trying to reduce the amount of earth moving, all right? And so we have the tower center. This is actually a model of the tower center. And then it's adjusted horizontally and vertically to minimize the earthwork. So they know where they want it, but it may be moved, tens of meters one way or the other to make sure that the amount of earth that needs to be moved to build that site is reduced. Because of the machine control, very minimal staking is required, and they really maximize the efficiency in the field. What the project manager told me is he had drivers that had been on the job for 2 weeks. They took the thumb drive with the data, put it in, and they started cutting pads. To give you an idea of the accuracy required for this this single pad, if they grade 2.5 centimeters low per pad, $10,000 in extra concrete. So the accuracy is real critical for them, okay? So in this case, the results, saving money. They were able to get their machinery that they had on site that they were paying back at work, within the 10 days. Construction began immediately compared to the 4 to 6 weeks estimated for traditional methods. So this just shows one of the pad sites. It shows you the size of the pad site, and then that gets filled with cement. So you can imagine 92 pads getting filled with that amount of cement. That's a lot. I'd love to have that contract as a cement contractor. All right. So not only the results included saving the client time. So again, the survey resolution. What's nice is that now they have data, because sometimes we were collecting data between sites. So we still have that data, in the archive that we can then use for them if they want to put additional pads and roads in. Again, the traditional LiDAR is, traditional survey is 50-foot spacing. The LiDAR is less than 1 foot. We're getting multiple points, like I was talking about, 40 points per square meter. That's our typical deliverable, is 40 points per square meter. The more accurate machine control files, less dirt moved, significant savings for them. Construction resumed with minimal delays, and the cost and time saving, again, with the survey and GPS control for that site. Again, this just shows the design of the pad itself before they put the topper on and do it. But it's, the number of bolts here are pretty significant because these things are getting hit with winds that sometimes are, last week we had winds that were 120 kilometers an hour. So a little bit breezy. So this is my last slide, but what it talks about is what's the results, saving the customer money. So I talked about the busted survey, right? So their survey that they had, their terrain model, showed 5,000 cubic yards of extra cut, all right? So they were gonna have 5,000 cubic yards of dirt to move off-site to sell. Each one of these trucks, the symbol, equals 125 truckloads of 40 cubic yards each. So pretty significant. Each one of these equals 125 trucks. This is what their survey said. This is what our survey said. 3,025 truckloads of earth they needed to find, not move off site. They needed to go and contract. They would have, if they would have went with this, contract over 3,000 truckloads of dirt to actually go off site and move on site. So depending upon the distance, the amount of cost was significant. How much? $1 million. So when the customer told me we saved him $1 million, I said, oh, excuse me, we missed a decimal point in our proposal, right? But it's significant, real significant. And because of that, that's why the customer's given us 6 additional projects doing the same sort of thing. So not only the difference of $1 million in moving dirt, but also 2 to 3 months of time saving for that customer as well, which for them, every day that turbine is up and spinning, they're making money. So the quicker we can do it, the more money they make. So that gives you an idea of how we've used the VX20 in terms of I call it land development, it's kind of the AEC space. It's one of our bigger markets that we sell into. We're extremely happy with the results we get with the YellowScan technology. We're proud to represent them, but I'm happy we use it because of the results that we get, consistent results, very consistent results.